Alright, so it says use the definition of continuity to prove that the function is discontinuous at the given value of a. We're trying to prove that it is discontinuous at a is equal to 0. Just like the other problems, this is like saying x is equal to 0. Alright, so we're going to sketch the graph of the function as well. So real quick, let me go ahead and make a quick sketch. And I can see that e to the x, which normally would look like this, is only going to be defined everything less than 0. So I'm going to go ahead and open this up here and then graph to the left. This other function x squared greater than or equal to 0 is going to be starting at the origin, and it's going to be to the right. And there's our two pieces of this piecewise function. Now notice, if I want to show that it's continuous, we know that there's going to be a jump discontinuity of some kind. It is a non-removable, because remember, removable versus removable is the removable is just one point, one x or one y value that it's missing that would otherwise enable it to be continuous. Alright, so looking at this is a non-removable, just jump discontinuity. Let's go ahead and go through the proof. Step 1, is f of c defined? Our c or x value that we're looking at is f of 0 defined? F of 0 is defined. Using this piecewise function where it is equal to 0, as shown here, we're going to say that f of 0 is equal to 0 squared, which f of 0 is equal to 0. The second step. The second step is to see both one-sided limits as far as the limit existing, yes or no. Now, as you can see, this is a form of jump discontinuity. We're proving that it's discontinuous for the fact that this limit does not exist. This limit does not exist at x is equal to 0 as far as a general limit. So if I say the limit of f of x as x is approaching 0, it does not exist. We're proving that it does not exist by the fact that the two one-sided limits do not equal each other. Okay, so that is the difference as far as compared to 5 and 6, is that we know the limit does not exist, and we're just going to quickly show how the left and the right-sided limits don't equal each other. This is showing that proof. So the limit of f of x as x is approaching 0 from the right is going to be on this piecewise function, and we're going to say that this is equal to 0. Okay, we know it exists, we know it will equal 0. It's basically showing that it's continuous from the right. Let's do the left-sided approaching limit, this one coming from the left. We're going to say that the limit of f of x as x is approaching 0 from the left, it's going to be equal to 1. Because if we approach it, we're saying here, we're saying the limit of e to the x as x is approaching 0 from the left, it's basically just plugging in e to the 0 is equal to 1. Obviously, 0 and 1 do not equal each other. That's why the general limit does not exist. Okay, so we're proving that the function is discontinuous for the simple fact that our theorems don't hold, basically. These rules don't hold because 2 automatically is false. So it's going to be discontinuous. You don't even have to go on. But go ahead and put therefore f of x is, or sorry, in this case it's h. And if you put f of x, I'm not going to count off for the test. Like here, technically you should have put h of x, and you should have put h of x here, but I'm not going to count off. This should have been h of 0. I know that you know you're talking about the function. So therefore h of x is discontinuous at a is equal to 0. And we showed by our prior work, especially this part right here.